In this video, we will continue differentiating trigonometric functions. So to begin, we will find the derivative of the function y equals tangent x. And at first glance, it may appear that this is a difficult problem, but the observation to make is that tangent can be written in terms of sine and cosine, and sine and cosine are functions that we can individually differentiate. Recall the derivative of sine is cosine, and the derivative of cosine is minus sine. And these are two formulas that we will use extremely frequently, so you definitely want to make sure that you have these committed to memory. Now that we have tangent written as sine over cosine, we can differentiate this via the quotient rule. So let me first just write out what the quotient rule tells us. It tells us low d high, so the bottom function times the derivative of the top, minus high d low, so sine, times the derivative of cosine, all divided by the bottom squared. Now that we have it written out in terms of what the quotient rule tells us, the thing to do is to look at the two easier derivatives that remain and to evaluate them via these common formulas. So the derivative of sine is cosine. So the first term becomes cosine squared. We're subtracting away, and note that the derivative of cosine is minus sine. So what we really have in that second term is minus sine times minus sine. A minus becomes a positive, and that would be sine squared. And this is all over cosine squared. Cosine squared plus sine squared by the Pythagorean identity is just 1. So the derivative of tangent is 1 over cosine squared. But it's worth also recalling that secant of x is defined to be 1 over cosine, which means 1 over cosine squared can also be written as secant squared x. And this is going to be another very common differentiation formula that we want to make sure that we know. The derivative of tangent is secant squared. Now, from a big picture perspective, what this last example is illustrating for us, if we take any of the remaining trig functions, so tangent, cotangent, secant, or cosecant, we can rewrite them in terms of sine and cosine and use the quotient rule to differentiate them. And if we do, we'll get the following differentiation formulas. So we just found that the derivative of tangent is secant squared. Using this same exact procedure, the derivative of secant is secant tangent. The derivative of cotangent is minus cosecant squared. And the derivative of cosecant is minus cosecant cotangent. Now, especially the top two formulas will be formulas that we encounter frequently. So once again, you should understand how to come up with them if you need to, using the quotient rule. But it's also worthwhile to maybe remember these formulas. And I don't necessarily suggest memorizing, but I think that we will use them enough that you will become familiar with them. So one more example. Let's find the derivative of the function 1 plus sine x over cosine x. So the function that we're looking to differentiate, so let's rewrite it here, y of x is 1 plus sine over cosine. This is a quotient of two functions, so the quotient rule will be an ideal approach. So y prime of x will be low d high, so cosine x multiplied by the derivative of 1 plus sine minus high d low. So that would be the top times the derivative of the bottom. And this is all divided by the bottom square. And now we go ahead and evaluate the remaining two simpler derivatives. The derivative of 1 is 0, and we add on to that the derivative of sine. which is cosine. We're subtracting away 1 plus sine multiplied by the derivative of cosine, which is minus sine. The first term in the numerator is cosine squared. Note in the second term, we have this extra minus sign, and we can combine that with the minus sign we already have to turn that into a plus. And then we can go ahead and distribute the sine term to both of those throughout. So that would be plus sine squared. And this is all over cosine squared x. So this would certainly be a formula representing the desired derivative, but whenever we can do a quick simplification, we certainly should. And in the top we have cosine squared plus sine squared. By the Pythagorean identity, that's 1. So the numerator simplifies nicely to 1 plus sine x, and this is all over cosine squared of x.